Hey everyone, welcome to This Explainer. Today we're taking on what is, frankly, a notoriously intimidating mathematical concept. But here's the thing, it literally powers our modern world. We are going to crack the code of classical electromagnetism by looking at the Lorentz force. Okay, let's dive into this. Because I want you to start by thinking about a really wild question. What connects the spinning motor inside your electric vehicle to the breathtaking glowing colors of the northern lights? I mean, it seems like a massive stretch, right? Everyday technology on one hand, and this natural, atmospheric wonder on the other. But as you'll see, the answer to both lies in the exact same invisible forces. So here's our flight plan for today. We'll cover 1. The master key, 2. The electric gas pedal, 3. The magnetic steering wheel, 4. Trajectories in motion, and finally, 5. Real-world applications. Kicking things off with Section 1, the master key, the fundamental equation. We owe this entire framework to a brilliant Dutch physicist named Hendrik Lorentz. He established what's widely considered one of the absolute fundamental pillars of classical electromagnetism. His legacy is the Lorentz force, which is the total force exerted on a charged particle as it moves through a region containing both electric and magnetic fields. Think of this equation, F equals Q times E plus V cross B, as the ultimate master key. Literally, if you want to understand or control the invisible world of charged particles, well, this is the code you need to crack. Now, I know an equation with a cross product can trigger some high school physics flashbacks, but let's quickly decode these variables together so it's not overwhelming. F is our total Lorentz force, measured in newtons. Q is the electric charge of our particle. Inside the parentheses, E is the electric field intensity, V is the particle's velocity, and B is the magnetic flux density. And that little x right there, that's our vector cross product. By breaking it down like this, we can actually see that this single equation is really a story of two distinct characters. Moving right along to Section 2, the electric gas pedal, the electric force. If our master key equation is a vehicle, the electric force, that Q times E part, is the raw muscle. Looking at just the first half of our equation, we isolate the electric force, or Fe equals Q times E. So the crucial point here is that this force actually does work on the particle. In physics terms, that means it does the heavy lifting. It actively changes the particle's speed, and thereby changes its kinetic energy. It's literally hitting the gas pedal. And where exactly does it drive the particle? Well, that depends entirely on the charge. If you have a positively charged particle, the force pushes it in the exact same direction as the electric field. Simple enough, right? But if it's a negative charge, like an electron, it gets pushed in the exact opposite direction. Positive goes with the flow, negative kind of likes to be difficult. It's simple, direct, and incredibly powerful. Which brings us to Section 3, the magnetic steering wheel, the magnetic force. So, if the electric force is the gas pedal, the magnetic force is the ultimate backseat driver. Our formula for the magnetic force is Fm equals Q times V cross B. Because of that cross product, this force is always perfectly perpendicular to the motion of the particle. And because it's perpendicular, it does absolutely zero work. Let's translate that into plain English. The magnetic force can never, ever change the speed of the particle. It only ever changes the direction. It steers, but it never, ever hits the gas. Now, what's really interesting about this slide is the perfect division of labor here. You have the electric force, which changes speed and actively does work, versus the magnetic force, which only changes direction and does zero work. They are absolutely perfect complements to one another. So how do we know which way it steers? I actually want you to put down whatever you're holding right now, free up your right hand, and do this with me. This is the famous right hand rule. Okay, step 1, point your fingers in the direction the particle is moving, its velocity, v. Step 2, curl those fingers toward the direction of the magnetic field, b. Step 3, look at your thumb. Your thumb is now pointing in the exact direction of the magnetic force, F. You've just physically mapped out invisible vector mathematics right there at your desk. But before I move on, remember our golden rule of charges. Opposites change everything. That right-hand rule works perfectly for a positive charge. If you're tracking a negative charge, like an electron, you just flip the script. The force acts in the exact opposite direction of where your thumb is pointing. Keep that in mind because it completely dictates how these particles travel through space. All right, Section 4, trajectories in motion, the dance of particles. When you combine the gas pedal and the steering wheel, you get a highly choreographed dance. And this brilliantly illustrates the special cases of motion purely based on the angle, theta. Theta is simply the angle between the particle's velocity and the magnetic field. That single angle dictates the entire resulting trajectory. Let's see how this math forces reality into some very specific shapes. Let's walk through these 3 specific mathematical outcomes. First, if the angle is 0 degrees or 180 degrees, the magnetic force magnitude is 0, and our particle just cruises along in a straight line, completely unaffected. Now, if the angle is exactly 90 degrees, the force is at its absolute maximum, completely perpendicular. This locks the particle into a perfect, continuous circular motion. But here's where it gets really beautiful. What if the angle is somewhere in between, greater than 0 but less than 90? Well, you get a combination of both. The particle continuously moves forward while simultaneously being turned, resulting in an elegant helical or spiral motion. The pure math fundamentally dictates the physical reality. It's just so cool. Let's bring it all home with Section 5 Real-World Applications, Powering Our World. Let's build from abstract formulas to concrete technology. Honestly, without the Lorentz force, our modern technological landscape would literally grind to a halt. Take electric motors, for instance. That rotation comes directly from the force exerted on current-carrying wires positioned inside a magnetic field. Because of the right-hand rule, a force pushes one side of a wire up and the other side down, spinning the rotor continuously. That's your EV motor. What about mass spectrometers? These devices identify chemical substances by shooting them through a magnetic field. Because of the math we just learned, heavier ions will take a wider curve than lighter ones, allowing us to sort atoms perfectly by their mass-to-charge ratio. And cyclotrons, they use these exact forces to accelerate particles into massive high-energy beams. The magnetic field acts as the steering wheel, keeping the particles trapped in a circular spiral, while the electric field acts as a gas pedal, giving them a kick of speed twice every revolution. This drives cutting-edge medical and nuclear research forward. But for all of our incredible human engineering, the grand finale of classical electromagnetism really belongs to nature itself. The absolute most beautiful application of Hendrik Lorentz's equation is the aurora borealis. Remember that helical spiral motion we talked about a few slides ago? Well, when charged particles are violently ejected from the sun and hurtle towards Earth, they hit our planet's magnetic field, but they don't just stop. They get caught by the Earth's massive magnetic steering wheel, and they're forced into a sweeping, majestic helical dance, spiraling down toward the poles. Why the poles? Because that's exactly where Earth's magnetic field lines naturally converge, funneling these incredibly energetic particles directly into our atmosphere. There, they violently collide with gases like oxygen and nitrogen to light up the sky and those vibrant greens and pinks. It's just incredible to think that the exact same mathematical equation governing a tiny spinning wire in your car motor is painting the sky at the edge of the world. So my question to you is, next time you start an engine or look up at the night sky, will you see the invisible cross products at work? Thanks for exploring this amazing concept with me, and keep looking for the invisible forces all around you.